Hey everyone, this is Jason from OrganicChemistOnCall.com again. In our last video we talked about naming simple alkenes, and now today I want to do a little bit more of a complicated structure and work through that. So as we talked about last time, and I'm pretty sure you all are familiar with, if you have one carbon it's meth, if you have two carbons it's eth, and so forth and so on. So here's the structure that we're going to be working with. The one thing I want to point out, and I always like to point out, is that anytime you see a kink, a bump, whatever you want to call it, or an endpoint, that represents a carbon. Now we're not worried about how many hydrogens are on each carbon at this point in time, but we just want to identify where the carbons are. So the first thing that we want to do is identify the longest carbon chain. And we'll notice that if we just simply go from left to right, we can find an 8-carbon chain. Now although this is the longest carbon chain, or I guess we could say one of the longest carbon chains on here, we'll notice that it does not contain our alkene. So what we want to do is take carbons 6, 7, and 8. We want to put those down in the bottom. So now we can see that we've got our longest carbon chain, which is 8, and it includes our alkene. Now as we know, when we're talking about our functional groups, we want that to have the lowest number possible. So if we just reverse these numbers, now we've got our 1 on our alkene, and then we can walk that through. Now when we're talking about carbons, as we've talked about, when we're dealing with those, we use meth, eth, prop. But when we've got side chains, what we have to do is modify those, and instead of meth, it's methyl if we have one carbon. It'll be ethyl if it's 2, propyl if it's 3, and butyl if it's 4. So going back to this structure, we'll notice that our longest carbon chain is going to be 8, which is oct. Now what we want to do is we have to go through and figure out what to do with this bromine, this, what we now know is a methyl group, and the propyl. So I'm going to highlight the longest carbon chain here, and let's focus on just the 3 carbons that have our substituents on them. So just to go ahead and name our base, we know it's 8 carbons, which is oct. We're going to add our suffix, which is ene, and that's octene. And we notice it's on the 1 position, but as we've talked about before, that you could write 1, but typically when you have a 1 position it's understood, so you leave it in this case just as octene. Now if we go through each substituent, we'll notice that the 4 position is a propyl. We'll notice the 5 is a methyl. You can see that we're adding our YLs. And now when we get to 7, we've noticed up to this point that when we're doing substituents we modify the suffix, or we add a suffix, I guess in this case. With bromine, obviously it's not going to be bromine, or the halogens aren't going to be just bromine or chlorine. What we're going to have to do is modify the INE, and the way we do that with halogens is we change that into an O, so bromo, chloro, so forth and so on. So now that we have all those, we just go ahead and put them together, not in numerical order but alphabetical, and when we finish off our name we get 7 bromo, 5 methyl, 4 propyl octene.